So this is the title of my talk. Let me just sort of move this. Okay. The idea is my laboratory, as you mentioned, was concerned with studying the fine details of neural circuits, leading ultimately to this book with Simon Laughlin that appeared first in 2015. And the idea of the book is that the brain is smarter than a supercomputer, but uses 100,000-fold less energy in space. And this efficiency is fostered by 10 principles of efficient design. Now, the body uses 80% of our total energy, so it must also be efficient. And to achieve this, the brain predicts the needs of the body and regulates our physiology and our behavior to meet them. Now, Joseph Iyer and I called this allostasis, stability through change. And recently, I've updated the story in Trends in Neurosciences with Jay Shulkin. Now, my new book, What is Health, asks, what does our species require for a healthy life? And can we achieve this with drugs? It also asks, why did our species, Homo sapiens, invest in art? Now, I'm well qualified by my biosketch and all the papers I've published on neuroscience to discuss neural circuits, but art and evolution maybe less so. And yet, what qualifies me here is that I have been a social activist, and there's been an interplay between my lab studies and my social activism. And so the book and this talk reflect how I've lived. So this was my first scientific report in May 1961 at Cornell University. I was an undergraduate. And upon submitting this report, I left Ithaca, New York, where Cornell is, for Mississippi to join the Freedom Rides. Now, many of you may not know that this was a mass movement, including many students, Black and white students, who took buses and trains to Jackson, Mississippi, to fill the jails to end racial segregation in public transportation and public facilities. So this clip that I'm going to show you surfaced a few years ago. We're 10 minutes, I'm on the train with some white and other Black students from we're going to Jackson, Mississippi, and the speaker in this interview is me.
How about you? Can you give me any of your feelings on why you want to take part in this?
Well, I want to help establish the right of all Americans to eat together and to travel together.
Why do you think it's your responsibility?
I think it's every American's responsibility. I only think that some are more conscious of their responsibilities than others.
So 30 minutes later, we were in jail and processed. And my concern after this for social justice persisted. So the next it is the mid-1960s in Cleveland, Ohio, which was an industrial city, which is extremely segregated and Black and white. And now I'm a graduate student studying motor pathways under Henricus Kuipers from the cerebral cortex. And the motor pathways get down to the spinal cord by this corticospinal tract. And that's what I was studying. But at the same time, I was slipping away from my microscope to canvas door to door in Central, which was the poorest Black ghetto. And the people answering my knock were often partially paralyzed. They were limping, their face, one side of the face would sag, their speech was slurred. And when I went back to the lab, I learned the immediate cause was destruction of these very pathways, these corticospinal, cortico-brainstem pathways, by stroke caused by chronic hypertension. Now, my grandfather, it turned out, had lived in Central when it was a Jewish ghetto, 40 years previously, 50 years previously. And I recalled that my grandfather also had suffered hypertension and an early stroke. So it seemed, I wondered whether maybe hypertension was related to social tension. So fast forward now to my own laboratory at the University of Pennsylvania School of Medicine, studying fine details of the brain, but I was still slipping away, but now to the library to find evidence for what is the cause, actual molecular and physiological cause of hypertension. I was also devouring ethnographic studies to learn how other peoples live. And soon I was slipping away to visit indigenous communities in Central America. And now I live half of each year in the mountains of Western Panama in a community of subsistence farmers and indigenous workers. So here's what I learned. First, the blood pressures of foragers, people who live as foragers or horticulturalists far from civilization, their blood pressures are low and steady with age. So for example, this is a Nobe indigenous family waving to us as we walk by, and they live on Panama's Caribbean slope, which is 2 days walk from the nearest market. So their blood pressures are low. And this is also true for similar groups in Southeast Asia, South America, and Africa. But in the US and in Europe, blood pressures rise as children enter school. So this is age down here. This is systolic blood pressure. And you can see that just about the age that we leave our families and go to school, blood pressures start to rise. And by graduation in the US, 25% reach the hypertensive range. So this reflects sustained physiological arousal. And in the US, the rise is steepest for African Americans because they are the most stressed. And that's because in the US, Black lives still don't matter. This is still a big problem, as I'm sure you know. So blood pressures, turns out, respond to each change in mental state. So this is a time here. This is a 24-hour recording of a man who's has an indwelling arterial catheter, and his blood. This is atrial blood pressure, and this is his systolic blood pressure, and this is the diastolic pressure. And what this shows is that we're told you have a blood pressure, but it's really not true. Your pressure, you have an average blood pressure, but it's really fluctuating all over the place. And so, for example, at this point, it's 1500, and the subject is in a lecture, and he's beginning to doze, and his blood pressure goes down. At this point, his neighbor jabs him with a pin. His brain predicts danger, and so it raises his pressure. And then he realizes that it's a prank, and the pressure falls back down. There are other various unidentified peaks and valleys, but at midnight, he's sexually aroused, and his brain predicts a need for a higher pressure, raises the pressure, and following his sexual activity, he sleeps and his pressure falls profoundly. And then in the next day, he's getting ready, coping with his life and his family and work, and his pressure rises essentially nearly into the hypertensive range. So this is allostasis. The brain recognizes the context, predicts the need, and adjusts the pressure to match, to respond. It provides, the idea is to provide just enough and just in time. And this is a slogan of Toyota, actually, that wants its assembly line to have not too much, just enough, just in time, because that's efficient. And I want you to note the wide dynamic range that covered by this system. It's very responsive. And this is what I claim is health, is responsiveness. So arteries adapt to predicted mean pressure. And here's the record I just showed you. And here's the mean pressure is around 100. And this is what the arteries would look like under these conditions. The healthy artery has modest walls of muscle that are used to pump the blood, but they don't block it. This is a recording from somebody with chronic hypertension whose mean pressure is near 160. And this is what their arteries would look like. So the lumen is narrowed to make the blood. They require high pressure just to force the blood through. And the reason is that arterial muscles, they're smooth muscles, but they respond to high pressure just like your skeletal muscles do to lifting weights. They get larger. So turns out that all mechanisms for blood pressure are controlled by the brain. The brain controls, for example, sends nerves to the kidney to control the amount of salt water that the kidney pumps into the vascular system or sheds. It also controls the heart rate and power of contraction. And these two control the cardiac output. And the brain also controls arterial vessels, and they control the resistance, and the combination ultimately sets the blood pressure. The brain, to my surprise initially, but this is well known now, also controls our appetite for salt. And so doctors, at least in the US, say, well, you shouldn't eat too much salt. People eat too much salt, and that causes hypertension. But the fact is that we eat salt because our brain says we need the salt. You need the salt to make salt water to pump into your vessels. And so a man who studied this experimentally for many years, J.P. Henry, concluded that psychosocial arousal induces a salt appetite, making a society's salt consumption a measure of its social stress. Now, we have drugs to block each of these mechanisms, but the brain knows where it wants to set the blood pressure, and so it compensates. So, for example, the brain in the kidney, we can give a diuretic, and it causes the kidney to shed salt water and therefore reduce the plasma volume. But the heart increases its rate. The brain tells the heart to increase its rate. And we can block that with what's called a beta blocker. But then the brain tells the arterial vessels to increase their resistance. And we can block that too. And then eventually, there are other mechanisms that can also be blocked. But eventually, the pressure can be controlled, but the system now cannot respond to new predictions. And I'm an old man now. I walk frequently with other old men, and many of them are taking beta blockers for various reasons. And they do okay, but when we come to a slight hill, they have to stop and slow down because their mechanisms to increase their cardiac output have been blocked. The other problem is that all of these drugs have multiple effects in various sites in the body. For example, a beta blocker causes, for various mechanisms, causes a rise in blood glucose, and that exacerbates type 2 diabetes, which is very bad for your cardiovascular system. And we can treat that too with more drugs, but the ultimate effect is to have an ill patient who is stabilized precariously by polypharmacy. And this of course is possible. It's a chancy thing. It's also extremely expensive. So now I'd like to consider some problems with U.S. health and connect those to aspects of our neural design. And finally, discuss a little bit what we need to do. So in the US, deaths of despair are rising sharply. This is a curve for US whites. Deaths of despair include drugs, alcohol, and suicide. And this plot is for men and women who are about middle age, born in 1970. And you can see that as we're rising, many countries in Europe are coming down, but some are beginning to rise. So you share some of the problems. This rise for males in the US with no education beyond high school is 4-fold steeper than this curve I'm showing you. And that's 60% of white males in the US. The UK, of course, and Canada and Australia are showing a similar trend, not as steep. Now, the deaths of despair in the US are rising steeply for the younger cohorts. And for example, this is a middle-aged cohort born in 1970. That cohort exceeds 100 deaths per 100,000 of despair at around age 45. But the younger cohort born in 1980 crosses that threshold line of 100, of 10 years earlier at age 35. So things are getting worse for the younger cohorts. Now, obesity is also rising from foods of despair, rich, sweet foods. And in the US, we have mass shootings, which are also rising from what I call murders of despair. And this is, I think, reflects a rising despair in the US that gun control is not going to cure. So what causes our collective despair? Well, first consider our huge brain. Our brain is 3.5 times that size of a chimpanzee, which is our nearest surviving relative. Our brain grows slowly in childhood, and particularly in our early years, it uses 60% of the total energy of the whole body, and that retards our physical growth until adolescence. Now, the growth of such a large brain requires care by 2 adult generations. And this is data. So this is age from 0 to 80. This is calories, net production of calories by hunting and gathering. And what I want to point out is that we have infants and even young children have a huge caloric debt, and only by age 20 are human adolescents, late adolescents, beginning to find there enough food to be net producers. And of course, this huge caloric debt is accompanied, as any parent knows, with a large emotional debt. So productivity peaks, continues to rise, and it doesn't peak until 45, and then we remain net producers as hunter-gatherers beyond age 60. And so for 200,000 years since the emergence of our species, gathering and hunting were challenging careers. They demanded prolonged study and practice. And this lent meaning to our lives. Now, the other point is that every brain is different. Our brains specialize to conserve energy and space, as I pointed out with Simon Laughlin in our book. And so this is a view of the left hemisphere showing cortical areas. We have about 200 specialized cortical circuits. And once we reach this limit of the number of specialized circuits, we couldn't individually become any smarter or skilled. So we specialized across brains. And we give, our species gives a unique set of circuits for each brain. And of course, this confers us with a unique set of innate abilities. Now, we practice our innate abilities, sports, music, art, literature, because that's most rewarding. And that produces eventually a community of experts, a hunter, a healer, a navigator, a musician, and so on. And communal intelligence will, of course, outcompete a design where all brains are the same. Now, this makes us awesome as a species, but there are costs, and one of them is mental distress. Another is interpersonal conflict, all the things that you guys deal with probably every day. Now, but to benefit from our communal intelligence, we must find ways to cohere. And this is achieved by sacred practice, various sacred practices, what words alone cannot express. And so the brain invested in costly circuits that don't bring in calories, but they go well beyond foraging. And so, for example, We had a cave art 44,000 years ago. We had cave music 40-odd thousand years ago. And I'm sure that the archaeological record doesn't preserve stories and humor. I'm sure we had cave humor as well. And all of these practices elicit intense emotions: awe, grief, joy, and laughter. And this releases tensions and fosters cooperation. So after 200,000 years of communal intelligence, we produced a steam engine. And the steam engine led to a tremendous explosion of productivity, industrial productivity. This curve is years. This is the introduction of steam engine, and this is carbon dioxide concentration in the atmosphere. And it's pretty clear that the steam engine was what kicked off this tremendous rise in CO2. Now, one of the problems, in addition to CO2 increasing, industry shrank the opportunities for challenging activities. And this was recognized very early by Adam Smith, the father of modern economics. Already in 1776, he said, "The man whose life is spent performing a few simple operations has no occasion to exert his understanding or exercise his invention. He naturally loses the habit of exertion and generally becomes as stupid and ignorant as it is possible for a human creature to become." This is quite a shocking statement for back then. But actually, I think we've not become stupid. The problem is that we are still smart, but we've narrowed the possibilities to exercise our innate gifts. We evolved to explore the planet, and we did. But now multitudes of us punch a ticket or scan a barcode. And jobs learned in minutes or days just present insufficient challenge for our large brains. And so this mismatch between our abilities and our opportunities to exercise them causes despair. So what links despair to compulsive consumption? We inherited a circuit that drives seeking. And this circuit rewards every unpredicted find, positive find, with a pulse of dopamine. And so here is, for example, a recording from a single nerve cell in a monkey where there's a dopamine signal. These are dopamine neurons. And when the unpredicted reward occurs, there's a pulse of dopamine from this single neuron. And from a pulse of dopamine, we experience a pulse of satisfaction, which allows us to pause in our seeking briefly. And as the pulse dissipates, our seeking resumes to serve the next need. And so foragers find food unpredictably, a root, a rabbit, something good, and they get a pulse of dopamine. They also find comfort unpredictably, a dry cave, a warm fire, and they get a pulse. So they have frequent pulses of dopamine, whereas we find food and comfort predictably, without effort, without surprise. And this is very convenient, but the problem is that predicted rewards provide less dopamine. So here is the same neuron when the reward is predicted, and you can see that it just doesn't increase its firing very much. So lacking these frequent pulses, we grow restless and we seek surprise. So when food is predicted, the only surprise that you can get from food is more or richer. And so surges of sugar and fat cause surges of dopamine. But if the surprise is more, the next surprise must be even more. And in the US, we go from a Mac to a Big Mac to a Whopper. I hope you maybe recognize those, those advertising terms. And the brain adapts to each of these surges by reducing its sensitivity. That's what all circuits in the brain and the body do. When there's a rise in the average level, sensitivity is reduced. So it's the same story for drugs. Alcohol, nicotine, cocaine, amphetamines, and opioids, all of the drugs that you guys deal with, evoke great surges of dopamine. That's why we seek them, but we soon adapt. And so I would like to say, in my view, drug addiction is not a substance use disorder. It is not any sort of a disorder. It is a natural effort to escape despair. And the problem is that we keep requiring more because we adapt. So the question is what to do. We now treat a despairing population for obesity, type 2 diabetes, hypertension, cardiovascular disease, and addiction. We treat them, or many people do. I think you guys may be ahead of the game at a molecular level with a whole panoply of drugs. But polypharmacy is not a plausible route to health, and it's very expensive. And so the first point is that health requires social inclusion. Everyone must feel that their lives actually matter. Reducing inequality reduces stress and despair, and thus improves health. So the second is health requires practicing our gifts across the lifespan. Automation now is progressively reducing job quality, but what we need now are not more jobs, but instead more challenging activities. Third, health requires expanding sacred practice to relieve the tensions caused by our innate mutual strangeness. Everybody's different, and so that causes problems. So now we click for products of sacred practice: Spotify, Netflix, ESPN, Pornhub, all these automatic sources of entertainment and stimulation. But vicarious experience cannot substitute for actual participation. So, conclusions. One, health is responsiveness, it's adaptation to continual change. It involves predicting future needs, and this minimizes the errors, and therefore it's efficient. Allostasis includes all of the processes that support this predictive change. So, for example, even in the earliest organisms, cyanobacteria had a molecular clock that tells it when to make new DNA, which is at night when the ultraviolet from the sun is at a minimum. It would damage the DNA. The worm brain, the first bilateral organism, predicts the needs of each organ, and then it learns to find the resources. It has a memory, and it learns to improve its behavior. So these molecular and neural circuits were optimized 500 million years ago, 500 million years ago. But now we try to tweak them with these drugs to fix the problems of the last 200 years. And the problem is that drugs that block these very complex, rich, ancient signaling pathways reduce responsiveness. So the fourth point is that our brain evolved for these individualized lives of physical, cognitive, emotional, and spiritual responsiveness, learning across the entire lifespan. And I think it's our responsibility to live such lives and to help others live them. So thank you. Now I'd be glad to hear comments and questions.